110 miles from the coast of mainland China, the island of Taiwan occupies a small, strategically vital position in the Pacific Ocean. Its mountainous terrain gives way to a narrow coastal plain, but it is not its physical geography that has made it central to the global economy. Instead, it is what happens inside a few highly specialized factories scattered across this compact island. These factories, operated by companies like TSMC, produce the overwhelming majority of the world's most advanced microchips. We are not talking about simple, low-cost semiconductors. As of late 2023, TSMC alone accounted for over 90% of the world's sub-10 nanometer logic chips, according to market research firm TrendForce. These are the bleeding-edge components that power everything from your latest smartphone to artificial intelligence data centers and advanced defense systems. Without them, the modern world grinds to a halt. You might think that if these chips are so crucial and their source so concentrated, then other powerful nations would simply build their own. But the reality is far more complex. The sheer scale of investment required to create an advanced chip foundry, known as a fab, is staggering. We are talking about facilities that cost tens of billions of dollars each, take years to construct, and demand a level of precision that defies imagination. It is a unique combination of geographic concentration, immense capital, specialized knowledge, and a singular technological choke point that makes this situation so precarious and so difficult to unwind. And it explains why Taiwan holds such an outsized hand in the global economic game. Building a modern chip fab is perhaps the most expensive industrial undertaking on Earth. Consider TSMC's current projects. In Arizona, the company is investing approximately $40 billion to construct 2 fabs, with the first expected to begin production in 2025. This is not just about the cost of land and concrete. These facilities are essentially massive, ultra-clean laboratories filled with millions of custom components and requiring vast, specialized infrastructure. Intel, another major chip manufacturer, is investing $20 billion in 2 new fabs in Ohio. Samsung is spending $17 billion on a new fab in Texas. These are not just large sums, they are sums that few companies, let alone countries, can commit to a single project, especially one with a construction timeline of 3 to 5 years before a single commercial chip is produced. The initial construction is only the beginning. Then comes the complex and costly process of installing equipment, calibration, and achieving reliable yield rates. Even if a nation could muster the capital and the political will to build such a facility, the next hurdle is far harder to overcome: the tacit knowledge and the highly specialized ecosystem that is developed around Taiwan's chip industry. Chip making is not simply a matter of following a blueprint. It involves thousands of intricate, often unwritten processes, perfected over decades by an army of highly specialized engineers and technicians. It is a culture of extreme precision, continuous improvement, and problem-solving that cannot be easily transferred. Taiwan has cultivated a dense ecosystem of suppliers, research institutions, and a workforce trained from an early age in engineering disciplines. The island boasts a concentration of highly skilled talent that is almost unmatched globally. This tribal knowledge makes new fabs in other locations inherently less efficient. For instance, TSMC's new fabs in Arizona face challenges including higher labor costs, cultural differences in work practices, and the difficulty of replicating the speed and efficiency of their Taiwanese operations, leading to reported yield gaps compared to their home foundries. This isn't a knock on American engineers. It's a testament to the decades of cumulative, highly specific experience embedded in Taiwan's industrial fabric. Beyond the capital and the human expertise, there is one more critical choke point that ensures Taiwan's centrality: the unique machines required to etch the microscopic patterns onto silicon wafers. To produce the most advanced chips, manufacturers rely exclusively on extreme ultraviolet, or EUV, lithography machines. And there is only one company in the world that manufactures them: ASML, based in Veldhoven, Netherlands. Each of these machines is a marvel of engineering, comprising hundreds of thousands of parts and costing around $200 million. They are so complex that transporting them requires 20 freight containers, 4 Boeing 747 cargo planes, and 30 trucks. Without ASML's EUV machines, it is impossible to produce leading-edge semiconductors. This makes ASML an indispensable single point of failure in the global advanced chip supply chain and, by extension, places Taiwan as ASML's largest customer at the heart of that dependency. This unique concentration of chip manufacturing has given rise to a controversial strategic concept, the Silicon Shield. The argument goes that the global economy's overwhelming dependence on Taiwan's advanced chips acts as a powerful deterrent against any military action by mainland China. The idea is that disrupting Taiwan's chip production would trigger an economic catastrophe so profound for the entire world, including China, that no nation would risk it. This theory suggests that the world's reliance on TSMC essentially forces major global powers to ensure Taiwan's stability. However, critics argue that this shield is double-edged. It might deter, but it also makes Taiwan an even more tempting target or potential hostage, highlighting its indispensable role rather than guaranteeing its safety. The irony is that the very strength of Taiwan's economic hand makes it a focal point for global strategic competition. In response to the perceived vulnerabilities exposed by the global chip shortage during the COVID-19 pandemic, several nations have launched ambitious initiatives to reshore or friendshore semiconductor manufacturing. The United States passed the CHIPS and Science Act in 2022, allocating $52.7 billion in subsidies for domestic chip production. Japan has also invested heavily in attracting TSMC to build fabs in Kumamoto. While these efforts are significant, they face substantial hurdles. The fabs being built, such as TSMC's initial Arizona plant, are often designed to produce slightly older and one-node chips, rather than the absolute bleeding edge found in Taiwan. Furthermore, the cost of manufacturing in these new locations is significantly higher. For example, reports suggest that chip production costs in the US could be 20 to 30% higher than in Taiwan, even with government subsidies. This cost differential impacts everything from labor to regulatory compliance and the availability of specialized supply chain components. It is a direct economic consequence of trying to replicate an organically grown, highly efficient ecosystem. Beyond the capital and the knowledge, the sheer physical demands of advanced chip manufacturing impose geographic constraints on where fabs can even exist. These facilities are voracious consumers of resources. An average large fab can consume millions of gallons of ultra-pure water per day, requiring sophisticated water treatment and recycling infrastructure. They also demand immense reliable supplies of electricity, often equivalent to the power consumption of a small city. Taiwan, despite its occasional water scarcity issues, has developed a robust infrastructure to support these demands, including a reliable power grid and advanced water management systems. Replicating this infrastructure in new locations, especially at the scale required for multiple fabs, is a monumental engineering and economic challenge, often overlooked in the rush to build new facilities. The stakes are immense. The concentration of advanced chip manufacturing in Taiwan means that almost every sector of the modern economy is vulnerable to supply shocks originating from this one island. From the automotive industry, which saw production plummet during the 2020-22 chip shortage, to the rapidly expanding fields of artificial intelligence, cloud computing, and advanced weaponry, these chips are the foundational components. A significant disruption in Taiwan's chip supply could trigger a global economic contraction estimated in the trillions of dollars, far exceeding the impact of previous financial crises. It would not merely be a setback, it would fundamentally alter the trajectory of technological progress and national security for decades. Taiwan was dealt a powerful yet precarious geographic and economic hand. Its small size, proximity to China, and position at the crossroads of global trade routes are now inextricably linked to its unlikely status as the planet's indispensable chip manufacturer. The combination of colossal investment, irreplaceable tacit knowledge, and a single, foreign-owned technological choke point means that unwinding this geographic concentration of power is a task of unparalleled difficulty. The global economy is built on a foundation of silicon, and that foundation, for now, rests overwhelmingly on an island just a short distance from the mainland. While Taiwan dominates manufacturing, the United States still leads in chip design. Companies like Apple, Nvidia, Qualcomm, and AMD are giants in the semiconductor industry, pioneering the architectures for everything from advanced graphics processing units to custom smartphone silicon. These companies operate on a fabless model, meaning they design the chips but outsource their production. And overwhelmingly, for their most advanced designs, they turn to TSMC. For instance, Apple relies exclusively on TSMC to produce the A-series and M-series chips that power its iPhones, iPads, and Mac computers. NVIDIA, a leader in AI accelerators, also entrusts TSMC with the manufacturing of its cutting-edge GPUs, which are now foundational for large language models and data centers globally. This deep integration means that hundreds of billions of dollars in American technological innovation and market capitalization are directly dependent on Taiwan's foundries. In 2023 alone, these fabless U.S. companies accounted for over 60% of the global fabless semiconductor market, according to the Semiconductor Industry Association, yet virtually all of their leading-edge products were fabricated in Taiwan. This creates a strategic paradox. The U.S. innovates the future of computing, but Taiwan physically builds it. The implications for national security and economic sovereignty are profound, as even the most advanced American designs cannot materialize without Taiwanese manufacturing expertise. Indeed, by 2030, analysts project that 90% of all high-performance computing chips essential for AI and advanced defense will still be produced in Taiwan. Consider that fabless U.S. giants like Apple and NVIDIA alone generated over $200 billion in revenue in 2023, largely from products powered by TSMC-made advanced chips. This intricate reliance underpins America's tech leadership. In fact, a 2021 Boston Consulting Group study estimated that shutting down Taiwan's semiconductor industry would cost the global economy nearly $3 trillion annually. Notably, U.S. firms like Lam Research and KLA also supply essential equipment to TSMC, creating a deeply interdependent global manufacturing ecosystem. This ecosystem extends further. U.S. firms, including Applied Materials, Lam Research, and KLA, collectively control over 40% of the global semiconductor equipment market. Their specialized deposition, etching, and metrology tools are critical for every advanced chip fabrication step. Without this American-made machinery, ASML systems lie idle. Subscribe to TradeWind, and the next video is waiting for you on screen right now.